Hey y'all, it's your main math teacher, Mr. Boyden. I'm back at it again today, and today we're going to be looking at multiplicity and zeros of polynomials. So by the time we get done today, we'll be able to take equations of polynomials and generate pretty good sketches of them. Last time we talked about end behavior, so today we're just going to be adding on. Okay, so if we're going to graph polynomials, we'll need to know how to find the zeros. Let's do a quick warm-up with a couple quadratics. What are the zeros? And we're going to sketch the graphs of these. I'd like you to try this one on your own, and I'd specifically like you to do it by factoring. So go ahead and pause the video and give that a shot. Okay, so here are my factors. Remember, we're looking for numbers that multiply together to be the second one and add to be the first one because our leading coefficient is 1. Okay, so here we have negative 2 plus 1 is negative 1. That is a 1, right? And then over here we have negative 2 times 1 is negative 2. Down on the bottom one we have x minus 4 and another x minus 4. Okay, so we were asked what the zeros were, so let's look at these and see what they are. You can glance at this one and see the number that would make that first chunk 0 is a 2. Plug in a 2. 2 minus 2 is 0. Negative 1 over here. Awesome. What about down here? What makes this 0? 4. What makes this one 0? Also 4. Interesting. It appears twice. Let's make sketches. Okay, so for the first one, I'm going to have a 0 at negative 2. So, at positive 2, my mistake. Okay, so over here at positive 2, we're going to have one at negative 1. And so we're going to have some sort of little parabola that goes like that, and that shouldn't have curved out. It should have just been straight up. Okay, so there's our first one. What about this second one? How is that one different? Okay, so I'm going to go out. I know that I have a 0 at x equals 4, so 1, 2, 3, 4. There it is. That's the only one. Now, you may recall that we can write this as x minus 4 quantity squared. Okay, so what that would tell us then, hey, this is a quadratic that's been shifted 4 units to the right, and it is facing up. So here it is. Okay, and I've made it a little bit wide for some reason. And I guess it comes up here and hits at 16. And we've got our y-intercept right there. Now, similarities and differences. Okay, so here's what I really want you to see. I want you to see that this first one, it comes down to the axis, it touches it, and it turns around and heads back up. Okay, it never goes over the axis into sort of negative land for these y values. Versus the first one, when it hits either of these zeros, it goes right through them. It slices them like an onion. Okay, it goes right through. It's not bouncing off. So there are some key features that we're going to see that cause that to happen. Let's look at a little bit, I don't want to say more challenging, but let's say more interesting example and see what happens. Okay, let's try this one. We're going to find the zeros of this one. Now we're talking about a cubic. Okay, so what we're going to do, we're going to try to factor it. Now, if that's a little bit of an amorphous task for you, then consider the following two questions. When you're asked to factor, ask yourself instead, is there anything that all the terms have in common? And is there anything that all the terms are divisible by? So let's see. They all have an x in common. And they're all divisible by 2. So I'm going to pull out a 2x. I've now decided what to factor by answering those two easy questions. So what's left in there now? I have an x squared minus 2x minus 15. Okay. Now the other thing, and I would get confused with this when I was taking pre-calculus, I would always wonder, how do I know when I'm done factoring? Seems like I factored. Why do I need to keep going? Okay, it's this right here. They asked us to find the zeros. So can you name off all the zeros? Okay, you can look at this first chunk and you say, okay, the 0 of that is 0. Plug in a 0 there and it says 2 times 0, and that's 0. Are you able to look at this second chunk and read off the zeros? Probably not. Okay, so we're going to have to continue to factor. In this one, the terms don't have anything in common, so we're going to have to factor it like we do traditionally for a quadratic. Okay, so we're going to have an x here, and we're going to have a little x there. We're looking for numbers that multiply together to be negative 15, add to be together, or to be negative 2. So I think that's a minus 5 and a plus 3. So again, how do we know when we're done factoring? Well, can you look at this and read off the zero? Sure. 0, 5, negative 3. And make a sketch? Yeah, not a problem. Okay, so let's remember from the last lesson, we need to first identify the end behavior. So I'm looking right here. That tells me that the right-hand end behavior is positive. And that's odd, which tells me that it's alternating. So the left-hand end behavior is negative. Let's do some sketching. So I'm going over to 5. And I'm going over to negative 3. And there's another 0 at 0. And let's see, right-hand end behavior is positive, so I'm starting up high. I'm going to come down. I'm going to go through there. I'm going to come up through that one, and then I'm going to dip back down. Okay, and there it is. Now, I do want to point out one thing at this stage, and this is going to be for all polynomials. Polynomials are what we call a smooth curve. And that's kind of hard to explain. I mean, it just basically means there's going to be nothing jagged on the graph. It would not harm you. Another way of thinking about it is, would this produce a survivable roller coaster? So here's what I mean. If the people are up here in the roller coaster car, whee, and they're coming down this way, is this a roller coaster ride that would not kill them? Seems like it'd be okay. You go down a hill and you go up, then you go down again. And here's what I mean. Sometimes in class, I'll see people draw things like this. So they'll have their zeros, and they'll go like, urch, urch, urch. Is this a survivable roller coaster? Well, let's see. Okay, we got the people on the roller coaster, and here they go. What happens to the people right here? Looks like they probably slam into a wall and perish. So please be careful that when you sketch these, it is a survivable roller coaster. Okay. The other thing that's going to happen with the roller coaster thing is sometimes we haven't seen it yet, but it's going to happen here in just a minute. Sometimes we want to bounce off the axis. And so people will do this. They'll make it bounce like a basketball or like a tennis ball. So again, survivable roller coaster or not. You go down in here, goes down into the pit, and bam, the people get smushed. Okay, so we're probably not going to do either of those. So just be careful. Make sure it's a survivable roller coaster. Okay, so one more thing we need to get before we can really feel confident in our abilities. We need to know if the graph will bounce or cross when we reach the zeros. Here's what I mean. Okay, in the example we just did, notice the way I sketched this, and I didn't address it at the time. I went right through the zeros. I passed on from the positive side to the negative, from the negative to the positive side of the x-axis, and then back down. And that's a little bit different than what we saw in those first examples. Okay, so up here, remember I talked about this bouncing off the axis and this one crossing through. So to understand this, let's look back at the equations that generated the two pictures. In this first one, you had a 2 and a -1. Here, you had a 4 and a 4. Okay, so what this is called, when you have two of these, that's called a double root. Okay, because what's happening, you have two zeros, but they're the same. So when you have two of them, which we're going to call that a double root, means the multiplicity is 2. What's going to happen is it's going to bounce off at that spot. Versus here, 2 only occurred one time, so its multiplicity is 1. -1, it was only a 0 one time as opposed to 2. So its multiplicity is 1, and that's why it's crossing through. So here's what you can add to your notes. How do you know when it's going to bounce or cross? You're going to know that it bounces when the multiplicity is an even number. And it's going to cross when the multiplicity is an odd number. Okay, now what is the multiplicity? It's just how many times that root occurs. Okay, so what we're going to do, instead of writing down a bunch of definitions, we're going to look at a bunch of examples. This is probably going to be best if you're following along if you have graph paper. If you don't, that's okay. Do your best, and I mean, it'll still be good sketches, but I'm going to be using graph paper for the rest of today's video. Here's our first example. So what we're going to do in this one, we're looking at the zeros already. It's in a factored form, so we can look and say, hey, what makes that 0? Plugging in a 0. Hey, what makes that whole term 0? If you plug in a 3. Now, we're going to identify the multiplicity and the degree and the end behavior. Another way you could think about understanding the multiplicity, if it doesn't make sense yet, is x squared means x times x. And so we have x times x minus 3 here. And so if you went down the line, what makes that 0? 0. What makes that 0? 0. What makes this term 0? A 3. So remember before, multiplicity is the same thing as how many times does the 0, or the root, I should call it, because it's not the number 0, it means where it hits the x-axis. How many times does it appear? This appears twice. And you can see that right here because it's squared. So its multiplicity is 2, which as we just learned means that it will bounce. Now in your notes, if you're not going to know what M2 means, then write multiplicity 2. And if you're not going to remember what B means, write the word bounce. Okay, what about 3? How many times does that occur? There's no exponents here, which means really it's to the first power, so its multiplicity is 1. I can now go down and put my zeros on the graph. I have one at 0. I have one at 3. I need to identify the degree so I can understand the end behavior. Now, in the previous video, I said that the degree is the largest power that you see, which is true when it's in standard form. And so standard form would be like if we distributed this, multiplied all those together, and then it would say x cubed minus 3x squared. And so that's why the degree is 3. Now there's another way to understand this. There's sort of a shortcut when you have a factored form. The degree will always be the same as the sum of the multiplicities. The sum, it's not sum of the multiplicities. And here's what I mean. If this multiplicity was 2, that multiplicity was 1. 2 plus 1 is 3. Okay, not a coincidence. That's always going to work. Now, we look, we go, okay, our leading coefficient's positive. So right-hand end behavior is positive. We have an odd degree, so we have alternating end behavior. So I'm going to start up above. I like to come down and put the little b on my graph. So I remember to bounce and I remember to cross. So here I go. Let's come down and make it happen. So I'm going to cross through. I'm going to start above the axis because my right-hand end behavior is positive. So I'm going to come down through this one, cross through, bounce off that one, and down we go. Make sure your sketch is a survivable roller coaster. Okay, you don't want to cusp here or anything like that. And notice, without me doing any thinking about it, because that bounced, it automatically took care of my left-hand end behavior. All right, this one's done. And by the way, for my test, this is the level of quality of sketch I'm expecting. It doesn't have to be beautiful. It just has to have all these key characteristics demonstrated clearly. Let's try this one. Okay, you may already be ready to pause the video and try them on your own. I'm going to go pretty quickly on this one, a little bit faster than the last one. Okay, here the 0 is 2. Its multiplicity is 2. I'm seeing that right there, which means that it will bounce. So 2, bounce. Right here, the 0 is 0. Its multiplicity is 3, which means it will cross. So we're going to cross over at the origin. Right here, a 5 would make that 0, and the multiplicity is 4, which means that it will bounce. So let's go out to 5. Let's see. I said the degree was the sum of multiplicities, so that would be 2 plus 3 plus 5. Or excuse me, plus 4. Multiplicity is 4. The 0 was 5. Plus 4. So that would be degree 9. And my leading coefficient is positive. Here's how I know that. This has a coefficient of 1. 1 squared is 1. This has a leading coefficient of 1, or excuse me, a coefficient of 1, and so that's 1. This has a coefficient of 1. 1 to the 4th is 1, and 1 times 1 times 1 is a positive number. Okay, so on my right-hand side, it's going to be positive. Odd degree means left hand is going to be negative. I'm ready to sketch. I always start on the right side, so I'm starting up here. I'm going to go down and bounce, and bounce, and cross. And notice again, the left hand end behavior took care of itself. At this stage, I think you're definitely ready to try them on your own. So again, pause the video and give it a shot. I'm going to go quickly. My zeros are 0, 0, negative 3, and 2, multiplicity of 6, multiplicity of 1, multiplicity of 7. So my degree is 14, and it looks like it's going to cross, cross, bounce. Let's get the zeros on the graph. So 0, negative 3, 2, and it looks like 2 is a bounce, 0 is a cross, and negative 3 is a cross. Okay. Again, I have a 1, and a 1, so the right-hand end behavior is positive, not BH. Right-hand end behavior is positive. The left hand is negative. Okay, so right hand, here we go. Bounce, cross, cross. Now, if you haven't noticed, I've made a mistake here, okay, somewhere, because right here I said my left-hand end behavior was negative, but using these characteristics at the zeros, I've made something that's positive, positive. So here's the mistake. Right here, I guess I didn't realize that that's an even number, which means the end behaviors needed to be the same. So it's an easy fix. It's just a plus. That's all. This example's a little bit different. In this one, we don't have a factored form, and you can tell that. You can't look at this and just read off the zeros. One of them maybe, but the rest probably not. So we'll need to factor it. Here's how it goes. We're going to look for the things the two terms have in common. They both have an x squared. Is there anything else they have in common? Well, they're both divisible by 3. So I get 3x squared multiplied by, looks like x squared minus 2. Let's read off the zeros. Okay, what makes this 0? That would be 0. Its multiplicity is 2, so it'll bounce. What about this one? It's tempting to say 2, but if you plug in a 2 right here, that'll say 2 squared. So 4 minus 2, that's not a 0. So here's what we do. We come over to the side, and we say, what would make x squared minus 2 equal to 0? Add 2 on both sides, take a square root, and you get x equals plus or minus root 2. Okay, now this gets kind of interesting. You got to realize this has two zeros, negative root 2 and root 2. And we're trying to understand the multiplicity. So remember, the degree will be the sum of all multiplicities. The degree on this one's 4. We already know that. Okay, so now you got to ask, what are the multiplicities going to be on these? It's very tempting to say 2, but keep in mind, the total multiplicity of this chunk was 2. And so the total multiplicity of these two roots is 2, which means they must each be a 1. And then 1 plus 2 equals our degree of 4. End behavior. Right hand positive because of this little 3 right here. And then looks like left hand is also positive because the degree is even. Looks like we're ready to sketch. Now, if you don't know, this is about 1.4. I'm rounding, right? But it's about 1.4. So for your sketch, you just come somewhere out in here and somewhere out in here. And then you have your 0 somewhere in here. And that's the one that's going to bounce. So here we go. So it looks like cross, bounce, cross. And it makes some sort of a W looking thing. Okay, that's all. So you could be on the lookout. You are going to have to factor at times. Okay, just again, we're just doing a whole bunch of practice. You'll have a whole library of examples to go from. It's a great idea to pause and try it on your own. This one I noticed right away it factors because it has an x in every term. So I can pull out an x, and I'll have x squared minus x minus 6. The way that factors looks like we need numbers that multiply to be 6 and add to be negative 1. So it looks like a minus 3 and an x plus 2 would do that. So therefore, my zeros are 0, 3, negative 2. All of them have a multiplicity of 1 because that's the only way the multiplicities will add to 3. My degree is 3. Oops, not b. Degree is 3. And it looks like my right hand end behavior is positive because my leading term is positive. And my left hand end behavior is negative because the degree is odd. Let's sketch. 0, 3, negative 2. Right hand positive. Everything's crossing. This is an easy one. Okay, the purpose of this one is just to get you a chance to try some different algebra. Okay, so there it is. And then sometimes you'll get one that's a little bit more fun, like this one. Okay, so I'm going to go a little more slowly on this one. If you want to try it on your own, that'd be fine, but I don't need you to try this one on your own. We could definitely do this one together. Okay, so what we're going to start with is exactly what we did on the previous examples. Okay, I noticed right away that they all have an x squared in common, so I'm going to factor out an x squared. In fact, I'm actually going to factor out a negative x squared because I really like it when my leading term appears positive. So then I'm going to have an x to the 4th minus x squared, because if you distribute, minus a negative, and then I'm going to have a minus 6. Okay, so already we can see one of the zeros is 0. This factoring here may look a little difficult though. So what I want to do is compare this to the previous example, because that wasn't so difficult. Okay, here's what I'd like you to see. In this example, see we have x squared minus x minus 6. We have a very similar form in the current question, x to the 4th minus x squared minus 6. So what we have to think about then, and we may have never talked about this explicitly, do we know why this has to be an x and that has to be an x? Okay, the reason why is because if you went to multiply these back together, your first move would be to distribute this x right there, and they would come out to be x squared. So let's consider the same line of thinking for our current question. Okay, so we're going to need to do some sort of factoring where whatever we write here and here need to multiply together to be x to the 4th. So let's try x squared and x squared. Now because we've done that, and that relationship of the fact that this power is twice as big as that one, just like if they were a 2 and a 1, this factors the same way as a quadratic even though it's a quartic equation. So what we get is a minus 3 and a plus 2, exactly the same thing as our previous example. Now let's name all of our zeros. Okay, what makes this term 0? If you plug in a 0, that would say negative 0. That certainly does it. Its multiplicity is 2 because it's squared. What about this one? It's not 3. Remember, we need to actually solve it. So x squared minus 3 equals 0. So x squared equals 3. And x equals plus or minus root 3. The total multiplicity was 2. So each of these has a multiplicity of 1. What about here? X squared plus 2 equals 0. So subtract 2 on both sides. So we get x squared equals negative 2. Take a square root of that. and you get square root of negative 2. So what does that mean? It means we have imaginary roots, or I'm going to write it like this: no real roots. Same idea as when a quadratic has no x-intercepts. It's still a viable quadratic, but it doesn't hit the x-axis. Okay, now this gets a little interesting for the multiplicity, because we started out with a degree 6 polynomial. So you have multiplicity of 2 right here, and what I really should have here is multiplicity of 1, because the negative gets 1 and the positive gets 1. And so we've only accounted for a multiplicity total of 4. So there actually is a multiplicity of 2 in here because of that little guy. It's just that that multiplicity is going to imaginary roots, and that's totally fine. So because there's imaginary roots, this graph actually has some wibble wobbles in it, and our sketch is not going to be quite exact. As far as the standards that I'm assessing, I don't need you to represent those wibble wobbles. What I do need you to show is that you know how to put a 0 there, and you know it has a multiplicity of 2, and that you know it's going to bounce off because of that you know that root 3 is about 1.7. So we're going to put 1 at 1.7, and we're going to put 1 at about negative 1.7, and you got to know, because those are multiplicity 1, they are going to cross through. You need to recognize the right-hand end behavior is negative, because you get that minus right there, and it's even, so the left hand will also be negative. And now we can sketch. So here I go, starting down low this time, and bounce, nice smooth curve, make sure it's a survivable roller coaster, and there is my graph. Negative, negative, I've got my zeros, I've got the correct behavior. There's something else going on funny because of those, but I have not worried about that for today's sketch. That's going to be all for today's video. Hope you enjoyed it, and we'll see you next time.